I have done some conversations with ChatGPT, which have mostly been about cosmology and atomic sciences. I put here the debate I had with him at different times about the expansion of the universe and the source of the redshifting of distant galaxies. Following is the first one you hear. If the observed redshifts of distant galaxies have been because of the matter shrinking, then there is no need to assume that the universe expands.
There is no evidence to suggest that matter in the universe is shrinking. In fact, the universe is expanding, which means that the distance between galaxies is increasing over time. While matter itself is not shrinking, the structures it forms, such as galaxies and galaxy clusters, can be affected by various physical processes that cause them to contract or expand. For example, galaxies can collide and merge with one another, leading to the formation of larger galaxies. However, these processes do not imply that matter is shrinking on a universal scale.
I'll show how atoms shrinking causes observing far distant galaxies to do redshift. We have evidence for redshifting of far galaxies, not the expansion of the universe. This is an interpretation of what we observed.
The expansion of the universe was first observed in the 1920s by astronomer Edwin Hubble, who noticed that distant galaxies were moving away from us and that the farther away a galaxy was, the faster it was moving. This observation led to the development of the Big Bang theory, which explains that the universe began as a singularity and has been expanding ever since.
Hubble observed that distant galaxies' elements are redshifting in the light spectrum received, not the universe expanding.
This statement is partially correct. While it is true that Hubble observed the redshifting of elements in the light spectrum received from distant galaxies, this redshift was interpreted as being caused by the expansion of the universe. The redshift observed by Hubble was interpreted as being caused by the Doppler effect, which is the stretching of light waves due to the motion of the source of light relative to the observer. In the case of distant galaxies, the redshift is caused by the expansion of the universe, which stretches the light waves as they travel through space.
As you said, this is an interpretation of what Hubble had seen. At that time, the only known cause of redshifting was the Doppler effect. I'll depict to you how another phenomenon can induce the redshifting process of far distant galaxies. Before that, I want to understand your opinion about some salient problems with the Big Bang theory and space expansion. As you know, the universe expansion needs an odd assumption, beginning from a singularity. But singularity is a mathematical concept and physically can't be conceivable.
The current scientific understanding of the origin and evolution of the universe is described by the Big Bang theory. According to this theory, the universe started out in a highly compressed state and has been expanding ever since. However, the concept of a singularity at the beginning of the universe is based on mathematical models and is not well understood, since it is impossible to directly observe or study what happened at that point in time. While the concept of a singularity at the beginning of the universe is currently considered to be a limitation of our current understanding of the universe, it is still an important part of the Big Bang theory and the current scientific understanding of the universe's evolution. As scientific research continues, we may gain a deeper understanding of the universe's origin and be able to better understand the concept of singularity.
Singularity is not the limitation of our current understanding of the universe. It is the limitation of the Big Bang theory. We should revise our methods of exploring and understanding the evolution of our universe. We know that the light spectra of elements are affected by changing the Bohr radius. So, by shrinking atoms over time, the corresponding elements must be blue-shifted. Consequently, the galaxy's spectra, which are due to their elements' energy absorption frequencies, should be blue-shifted over time too.
While it is true that the spectrum of electron light radiation can be changed by changing the Bohr radius of an atom, it is not correct to say that shrinking the atom's radius will necessarily result in a blue shift of the electron light radiation. The motion of an atom's electrons in their orbits is governed by the laws of quantum mechanics, and while changing the Bohr radius of the atom can affect the energies of the electron orbits, it does not necessarily cause the atom to move towards or away from an observer. Therefore, it would not necessarily cause a redshift or blue shift in the electron light radiation emitted by the atom.
I didn't mean that atoms move toward or away from us by shrinking, their emissions and absorptions energy are blue shifted over time. Changing the orbital energy level can shift the wavelength of the atom's energy. By reducing Bohr's radius, the wavelength of that radiation would decrease, and seems that the light is blue shifted. Therefore, emitted light in ancient times has a longer wavelength than that emitted in the current time. So, the ancient emitted light relative to the current one looks redshifted, and the new one for the ancient one seems blue shifted.
You are correct that changing the Bohr radius of an atom can affect the energy levels of its electrons, and that this can result in a change in the wavelength of the energy radiation emitted when an electron changes its level. If the Bohr radius were reduced, the energy levels of the atom would increase, and the frequency of the energy radiation emitted when an electron changes its level would also increase. This would indeed make it appear as if the light emitted by the atom were blue shifted. However, it's important to note that this effect would be specific to the atom in question and would not necessarily have any bearing on the redshift or blue shift of light observed from distant galaxies. As I mentioned earlier, the redshift observed in the light spectra of galaxies is due to the expansion of the universe, which stretches the wavelengths of light as it travels through space. This is a different mechanism than the one you described with the Bohr radius of an atom. There is no evidence to support the idea that the redshift of distant galaxies is caused by the shrinking of atoms over time. Additionally, the idea that atoms could shrink over time contradicts the laws of physics and would require a radical rethinking of our current understanding of the nature of matter.
If the mass of an atom steadily converts to energy over time, it would shrink continuously, and its emission wavelength blue shifts too. Isn't it a better idea than saying that space expands into nowhere? By the way, our model can have an infinite universe, while in the Big Bang theory, we cannot assume an infinite universe.
It is true that mass can be converted into energy through processes such as nuclear fusion or fission, and this conversion can result in a change in the size of the atom. However, this effect is not related to the observed expansion of the universe and cannot explain the redshift of light observed in the spectra of distant galaxies. The idea that space expands into nowhere is a bit of a misnomer. In reality, the expansion of the universe refers to the stretching of space itself, rather than the expansion of objects within space. As the universe expands, the distance between objects increases, but the objects themselves do not necessarily grow or shrink. This expansion is supported by numerous lines of observational evidence, including the redshift of light observed in the spectra of distant galaxies, the cosmic microwave background radiation, and the large-scale distribution of galaxies in the universe. The current scientific consensus is that the expansion of the universe is a consequence of the Big Bang, which is thought to have occurred approximately 13.8 billion years ago. While there is still much we don't understand about the nature of the universe, the expanding space model is currently the best explanation we have for the observed redshifts of light from distant galaxies.
We see that the theory for justifying the assumed expansion needs the dark energy.
Yes, the observed acceleration of the expansion of the universe is currently attributed to a hypothetical form of energy known as dark energy. This form of energy is believed to make up approximately 68% of the total energy density of the universe and is postulated to have a negative pressure that is causing the expansion of the universe to accelerate. While dark energy is still a theoretical concept and we do not yet fully understand its nature, its existence is supported by a range of observational evidence, including measurements of the cosmic microwave background radiation, observations of the large-scale structure of the universe, and the observed acceleration of distant supernovae. The concept of dark energy remains an active area of research in astrophysics and cosmology, and scientists continue to explore various theories and models to better understand its properties and implications for the evolution of the universe.